Welcome to the lesson on Diagnostic Procedure Live Dead Live Test. In this lesson, we will look at the importance of the Live Dead Live Test procedure, abbreviated as LDL test, and the steps involved in effectively disabling high-voltage systems to ensure the safety of technicians. Let us now look at our lesson objectives. By the end of this lesson, you will be able to explain the critical role of an LDL test to ensure safety when working on EVs, especially battery electric vehicles. Next, you will be able to describe the essential requirements for conducting an LDL test safely and effectively. Finally, you will be able to explain each stage, from setting up your equipment to interpreting the results and ensuring proper safety protocol throughout. So, what is an LDL test? An LDL test is a diagnostic procedure commonly used to assess the electrical insulation integrity of components within a BEV system. This test is critical for ensuring the safety and reliability of high voltage or HV electrical systems. It verifies that the HV components are completely de-energized before technicians perform any maintenance or repairs. This helps prevent serious accidents and injuries from electrical shock. Let us look at the reasons for conducting an LDL test on a battery electric vehicle, BEV. The primary reason is safety. The Occupational Safety and Health Administration, OSHA, mandates an LDL test before working on any HV system. This is the most important reason for conducting the test. It ensures the safety of technicians by verifying that the HV components are completely de-energized before any work is performed, preventing electrical shock and other potential hazards. Next is the meter and lead verification. Performing an LDL test helps ensure that the HV meter and its leads are functioning correctly. This is important because faulty equipment can provide inaccurate readings, leading to potential safety hazards. Next is the importance of setting the multimeter to the correct mode. A digital multimeter set to AC voltage can give false readings on HV direct current DC circuits, potentially leading to a mistaken belief that the system is discharged when it's not. An LDL test helps verify that the meter is set correctly and provides reliable measurements. This emphasizes the importance of using appropriate HV testing equipment and following proper procedures. Now, let us look at the tools needed for an LDL test, namely a digital multimeter, abbreviated as DMM, and test leads. A Category 3 DMM is a versatile tool that can measure multiple electrical properties, including voltage, current, and resistance for higher power distribution circuits. DMMs have a display that shows the measured value of the electrical property being tested. The primary concern when working on BEVs is safety. BEVs have HV systems that can pose a serious risk of electrical shock. Using a DMM with the proper CAT 3 and 1000 volt rating is important. This rating ensures the meter can handle the high voltages and voltage surges present in BEVs without compromising its safety or accuracy. Use a DMM offering at least 1000 VAC and 1500 VDC test voltage to thoroughly assess insulation health. Choose a DMM that can handle voltage fluctuations up to 8000 volts for added safety. Aim for a resolution of 1 nanoampere to detect even minor leakage currents, indicating potential insulation faults. Always refer to the manufacturer's instructions for your specific DMM and BEV model for detailed safety guidelines and compatible tools. Next, let us look at test meter leads. Test meter leads are cables that connect the DMM to the component being tested. The probes are used to make contact with the circuit or component being tested, and the wires carry the electrical signal to the multimeter. These devices safely and accurately measure electrical properties such as voltage, current, and resistance, and are an essential part of a DMM test kit. It is important to choose test meter leads that are compatible with your DMM and rated for the voltage and current levels you will be testing, as some leads are designed for specific types of DMMs. Let us now look at the safety requirements to ensure you are safe while performing an LDL test. Wear appropriate personal protective equipment that includes gloves rated for 1000 volts DC, safety glasses or face shield, flame-resistant and arc-rated clothing, and electrical hazard or safety footwear that are critical to ensure your safety. These safety measures help mitigate any risk that may arise while performing an LDL test. Working on HV systems requires extreme caution and adherence to safety protocols. Remember to always follow the manufacturer's specific instructions for your electric vehicle model, as they may have additional safety precautions or procedures for the LDL test. Here is an overview of the guidelines of the LDL, steps to help prevent electrical hazards and ensure a safe working environment. Step 1. Ensure the use of proper safety and tool equipment. Step 2. Set the DMM to the DC voltage mode. Step 3. Verify the functionality of the DMM with a known good battery. Step 4. Test the HV circuits. Step 5. Re-verify the functionality of the DMM. We will now look at these steps in detail. Step 1. Ensure the use of proper equipment. Use a Cat 3 1000 volt rated DMM and appropriate lead cables designed for working on HV systems. Do a thorough visual inspection of the lead cables and do not use damaged test leads. Follow all necessary safety protocols, including wearing appropriate personal protective equipment and ensuring the DMM is in good working condition. Step 2. Before testing any circuits, set the DMM to DC voltage mode. This ensures accurate voltage readings for both the low voltage and high voltage tests. Step 3. Verify the DMM's functionality by measuring the voltage of a known good 12-volt battery. Ensure that the DMM reads approximately 12 volts, indicating proper operation. Step 4. With the DMM still set to DC voltage mode, carefully test the HV circuits for the presence of high voltage. A reading under 3 volts typically indicates that most safety standards consider the HV circuit dead. Always refer to manufacturer service information for the correct voltage readings. Step 5. After confirming that the HV circuit is dead, retest the DMM on the 12-volt battery once again. This final step ensures that the DMM did not provide false readings during the HV testing and that it is still functioning correctly. Once all steps are completed, safely disconnect the DMM and leads from the circuits. Double-check that all safety precautions are followed and secure the HV circuits before proceeding with any further work. Let us now recap what we have covered in this lesson on the diagnostic procedure dead live test. Before touching anything on the vehicle, ensure the high-voltage components are completely de-energized. Use a Category 3 rated multimeter and wear appropriate personal protective equipment like gloves, glasses, and flame-resistant clothing to minimize the risk of electrical shock. Perform an LDL test to confirm that your HV meter and leads are functioning correctly, ensuring accurate measurements throughout the entire process. HV/BV systems use direct current. Setting your multimeter to the correct DC voltage mode is critical for accurate readings, preventing false assumptions and potential safety hazards. Use the proper equipment and PPE, test HV circuits for low voltage, re-verify your meter's accuracy, and disconnect safely before proceeding further. Remember to always prioritize your safety and follow your manufacturer-specific instructions when working on HV systems. Thank you.